was our pianist when we first came here. She was the church pianist. His dad was a school teacher with the Levelland ISD, and I think his mom was too. She had passed away before we came. Now, his dad was still alive when we came. But I think he did the cross at your church before he did the one at our church. Ours is inside, but it's got lights and shines through. It's like a stained glass with lights shining through, and it's got the reds, you know, lots and lots of colors. Let's see it on here. Anyway, his wife, like I said, she was our pianist, and it was so sad. She got pancreatic cancer, and she suffered for quite some time.
That's one like West Garza. That was the same thing for us. It was probably one of the hardest moments at our church.
Yeah, yeah. Well, you know, we knew Wes because when we'd have the Ministerial Alliance things, Wes would always incorporate some of it from your church, you know, because the Ministerial Alliance has a Thanksgiving service, community-wide service, and then we had it, 2 or 3 weeks ago, maybe 2 or 3 weeks ago, like before Easter service and community-wide. And the one that we just had was at the Assembly of God down by the square, kind of by the square, you know.
Yeah, I've seen.
And but yeah, but Wes was always participating, you know. He had to.
He was an amazing man.
Right. I need to remind, because you know, I guess you've probably heard about Miss August's daughter-in-law. Have you talked to her?
I have not.
Her daughter-in-law had a fingernail that wouldn't heal, like it was cracked, and it weeks and weeks, I don't know how long, months, you know, and they would say, oh, it's just a fungus, I'll give you some, you know, it's a fungus, I'll give you some medicine, you know, a prescription, and it'll heal up. Well, it didn't, and finally her gynecologist, when she was pregnant with the latest baby, said, you need to go see a dermatologist. Well, it's melanoma underneath that, and it's one, I think, a pointer finger. So they did surgery and took off that much of her finger. And then I don't know for sure what day this week they got the results back from the pathology report, because they took out lymph nodes too to see how serious. It's stage 3. She was in tears.
I have not seen her.
Yeah.
And
so
she's been a member of our church for
Right,
a very long
right.
time too. Like, I know all of her kids.
Right.
Her excitement of, you know, being a grandma one more time.
Right.
Like, because I was in her class last summer, so I got to see all of that. That's
right. So just keep her in your prayers. I mean, it's just.
I sure will.
Yesterday, I had been thinking about it. I would think of it either real early in the morning or late at night, of asking if they, you know, what the pathology report said, because I knew they were going to get it back, and I just kept forgetting. And then one of the other instructors, we're kind of close together there, you know, and we communicate a lot. She came to me, she said, Kathy, I just did the worst thing, Carol. I made Carol cry, and all. I said, no, you didn't make her cry, but she, you know. So after I got back from lunch, I just went into her, and she said, I can't talk about it. I said, I don't want you to talk about it, you just need a hug. So I hugged her, and I said, so do they have a plan? And, you know, what are they going to do? And she said, they haven't even been to a doctor. She said, I just want them to go get an appointment, make an appointment, and see. But I guess they, I can't think of her daughter-in-law's name. Daniel is her son. And I don't know if it's Tamara. I mean, there's lots of girls' names because she has the girls, you know. But anyway, it's been real. Yesterday was just horrible for her. Just horrible. So I don't know if they just got the report that day or day before, you know. But anyway, she was. Okay. We are going to start with finishing up the section on our application problems, and then I have had some questions about some problems in section 4.3 that I want to answer. so that those who have asked them can watch the video and get their questions answered. Hopefully, I'll work through those problems. And did y'all have any questions that you wanted to throw out there too?
As of right now, no.
Okay. Remember that part 1 of the test will be on Wednesday of next week, and then I think Sudan and Tahoka are taking part 2 on Thursday. Our students, and I need to talk to y'all after class, okay, will take part 2 on Friday, okay, of next week. But if you have any questions, come across any questions between now and Wednesday, you may email me. I will spend some time in my office on Monday, and then of course we'll be back in class regularly on Tuesday. But I do want to make a note, because I wrote myself a note. The review problems that I wrote or typed in at the bottom of this section 5152 application problems, those review problems will not be collected, okay? You focus on what you need to focus on. That's just the types of problems that your test will come from, or be similar to, of course, at least. And also remember that on Wednesday, part of the test, the first part of the test will be a timed piece with no calculator, like the arc sine things, okay? So we want to make sure, and I've given you some problem numbers from the textbook that it would be like, okay? So let me get going, and let's get started on, let me get to the right camera. Finishing up this, I think we were on the last page of these notes. I think we finished the problem before, right?
Yes, ma'am.
Okay. So this problem right here that I have says we've worked problems like this in section 1.5. Actually, I suggest, and this is typed in, that you go back and work the application problem, not plural, but problem, bonus from exam 1 using what we've learned now, log sines, log cosines, okay? That will help you understand how, back then we worked it one way. Now that we know a little bit more about our trig, it's somewhat, very much easier, okay? Now, this one here is not exactly like it. I mean, the picture is going to be, but the given information isn't exactly like it. So I think it's even a little bit more than what that one on your exam 1 was, as far as the steps to work it, okay? So let's read this problem. Double triangle, okay, where we have an angle of elevation, if you remember that, okay? The angle of elevation of the top of the building from point A on the ground, okay, so here's my point A on the ground, and I'm going to put my building, the top of the building, okay, this, and we draw our line across the ground, okay, so we're making us a triangle here. This angle of elevation is 24 2/10 degrees. Okay, from point B, which is 44 5/10 feet closer to the building, okay, here's my building over here, this vertical line, the angle of elevation is 38 1/10 degrees. So here, I'll make my point B right here, from this point up here to the top of the building, okay. This angle is 38 1/10 degrees. It says point B is 44 5/10 closer to the building, so that tells us from point A to point B it's 44 5/10 feet, because we're that many feet closer to the building. Okay, so the question is, what is the height of the building? So we'll put our X right here. That's what we're looking for, the height of the building. Now, this would be a very simple problem if we knew this angle up here, this whole side. We don't know this whole side. If we looked at the big triangle, okay, we would have this angle looking for the side opposite it, and if we had this angle, but we don't know this whole side. So that makes it a little bit more difficult. So we're actually going to have to think about this in 2 triangle pieces at a time, okay? So I labeled this one point C, so I could talk about triangles in here and angles. So at first, I'm going to look at triangle ABC, ignoring this one over here, and I want us to find the measure of angle ABC. So this angle right in here is what we're looking for. ABC, right here. Okay, so any thoughts? Yeah? What do you know straight line is?
180.
180, so we would take...
80 minus 38.1.
Right, okay. The measure of that one will be...
141.9.
Oh, wow. Minus 38.1, I'll get it written down. 141.9, you already had it figured. Okay, good deal. 141 and 9/10, okay? So I'm going to write that in here, 141 and 9/10 degrees for that angle, okay? Now then, let's find the measure of, well, and let's talk about why I would want that even, okay? If I can find this side right here, then I can use this triangle here to find my x, right? Okay, so we want this side right here, but I have to have, this is my only side measurement, so you have to think of what the given information is. We only have this one side measurement. We have lots of angles. So we need the angle opposite this side. So that's
180 minus 141.9 minus 24.2.
very good. Okay, this angle up here, very good. They're talking to me here. You may not be able to hear them, but they're answering correctly. ACB, if we get this angle up here, okay, I was told 180 minus 141 and 9/10 minus 24, excuse me, and 2/10. We don't want to make some kind of mistake like that. And what did y'all get?
13.9.
Good. 13. 13 and 9/10 degrees. Okay. So now, using our law of sine, okay, we have looking for this, and I'm going to just label it AB, segment, I mean not AB, but BC. We have AB given. We can find this one, BC, okay? Well, I'll label it Y, just for simplicity's sake, okay? So we would have this side is to this angle opposite it, so opposite it is to the sine of 24 and 2/10, as my side up here, 44, or down here, and 5/10 is to my angle up here, sine of 13 and 9/10 degrees. Everyone good there? Okay, so y'all do your cross product and divide so we can get the value for Y. And
79 or 75.9.
okay, 75. And that would be in feet. Now that we know this, okay, we know, and this would be because it's perpendicular to the ground, okay, your building would be perpendicular, you can use this other triangle, triangle BCD, because we've got an angle with its side opposite it. We've got another angle, and we're looking for the side opposite it. Okay? So we'll set up another proportion over here using our x. So we have x is to the sine of 38 and 1/10 degrees, as this value for y that we just found, 75 and 9/10, is to the sine of 90 degrees, because we have the perpendicular right here. So then we can find x doing a cross product. And of course, sine of 90 degrees is 1, so we don't have to do that. If you want to, you may. And we get
46.8.
okay, 46 8/10 feet. So you'd write a statement. The height of the building is 46 8/10 feet. Okay? Okay, let's look at this last problem, and then we're going to move to the ones that were sent in as questions, okay? If you remember from geometry days, the word chord, okay? You have a circle and a central angle. That means the vertex of that angle is at the center of the circle, central angle, excuse me, okay? And then the chord is not the arc, but the straight line from where the radius strikes the circle at each point. That would be known as a chord, okay? This is called your central angle, A, okay? The radius is R, okay? Intercepts a chord, not the arc. The arc is the rounded part of your circle. So we're going the straight line between those two where the radii intersect the circle. And of length A. So we're going to name this A. My chord is the length A. And of course our radius is R. And this should be the central angle. I put A instead of alpha because I use alpha in my formula here. Okay? So this A should actually be alpha. Sorry about that. So if we plug into this formula, okay, we can find the length of that chord. This formula, it says, is a direct result of the law of cosines. You can see the proof of it on page 271 if you want to follow that. So now, the problem that is given to us to calculate is to find the length of the chord intercepted by a central angle of 33 8/10 degrees. So that says this angle right here is 33 8/10 degrees. When they say the central angle, that's the angle from the center of the circle out in a circle of radius 22 4/10 feet. Now this is a problem just with numbers. There are application problems in this that I've assigned that go with this, okay? So you see how it applies in real life. So we're looking for the chord. So we have A equals, and my radius in this case is
22.4 feet.
okay, 22 4/10 feet, and then we're going to multiply that by the square root of 2 minus 2 times the cosine of my angle, 33 8/10 degrees. Okay, so just be careful that you plug that into your calculator correctly. All of this is under the radical sign. So if you're using a radical, you want it in parentheses. Well, you are using a radical, okay? You can do this radical part, but put it in parentheses as you put it into your calculator. And you better put this multiplication in your parentheses. Each calculator is a little different, so you figure out what yours is. And I'll give you that you should get that length to be approximately 13 feet. Approximately. Good? Okay. First try, yay. Okay. Then, I make a statement here about robotics. I'm not covering that, and it's not going to be on your test, of course, but if you're interested, you can turn to those pages. So now you need to complete the homework problems from sections 5.1 and 5.2 because I told you before you couldn't do all those application problems. Now you can, and then I've given you the review problems that you can prepare for the test. Yes, ma'am?
The test, is there going to be one like this length of this course, length of a course? Do we need to know that equation?
I'll give you this equation.
Okay.
Okay? I'll give you this equation. I'll just give the equation. I'm not gonna tell you what the pieces, what the variables mean, okay? Yeah, I'll give you that one, because that's not one that, you know, we just keep in our hip pocket or up here memorized all the time, okay? I will give you that. Okay. Okay, so let's move on. And one of the first questions, well, all of the questions actually have come from 4.3, okay? That must be and it is a little bit more challenging because you're having to use your identities, okay? So this is the part that you've got to go back and review those identities. Okay, so first of all, we know that the sign, because the sign function is an odd function, this would be equal to the negative sign of x, right? Pulling that negative out there. And this one, also tangent is an odd, okay? Now you remember, the only one that's even is cosine, so everything else is odd. So this will keep the negative, but we're going to pull it out front. And I'm actually going to change tangent to what we use as my other two trig functions. What is it? The relation?
Sine over cosine.
Okay, sine over cosine. Sine of x over cosine of x. Okay? Now, let me back up just a second. What this question is actually asking is, where is, well, from this point, okay, I could say it this way. Where is the opposite of the sine of x equal to the opposite of tangent of x? That's what if I just wrote it as the tangent instead of changing it, okay? Where would they be equal? So you can kind of get an idea of what you're looking for just by thinking of that. Where are the sine and the tangent, both negative, they're the opposite of them equal. Okay, but to solve this out, like algebraically, okay, with steps, let's set it equal to 0. Now, the question is, how do you know where to go? Well, if I've got two different functions, you know that more than likely you're going to need to set it equal to 0 and hope that you can factor something, okay, so that you can set those factors equal to 0. Now, it doesn't always work that way, but a lot of the time it does, okay? So I'm going to move this over here so it's a positive. So I have the sine of x over the cosine of x minus the sine of x, and that will be equal to 0. Now, like before when we were verifying, remember if we had something that had a denominator, we would get a common denominator? Okay, so let's do that same process. Let's get us a common denominator, which would be cosine of x, okay? So this first one is not going to change, sine of x, and then we'll have minus sine of x, cosine of x. So we're using a lot of the same procedures, okay, little hints from when we verified, over the cosine of x is my common denominator, and that's equal to 0. Okay. So now, what do you see from what I just said? What do you see in both of these terms in the numerator?
You can take out a sine of x.
Okay, we can factor out a sine of x, so let's do that. Sine of x, and then we have 1 minus cosine of x, but that's still, we still have that denominator so far, cosine of x in the denominator equals 0. So here we factored. Okay, then we don't want that denominator, so we're going to multiply, because that would just be a number value actually, okay? So we're going to multiply both sides by cosine of x so that we can get rid of this denominator here. Okay, so, and cosine of x times 0, of course, is still going to be 0. So we have the sine of x, and then 1 minus our cosine of x equals 0. Now then that we have a product here, we use our zero product property from algebra days and say the sine of x equals 0, or 1 minus the cosine of x equals to 0. So then we're thinking the inverse sign, okay? Inverse sign of 0 equals x. So we're asking ourselves, where is the sine of an angle equal to 0? And this was from 0 to 2 pi, I might point out also. So on our unit circle, where is the sine? What angle would give us the 0 value for sine? Sine is your y.
At pi and 2 pi?
Okay? 0,
Oh, yeah.
pi, okay.
Sorry.
2 pi. Okay. Okay, now let's look at this other piece, and let's isolate our cosine of x. So we would have 1 equals the cosine of x, so that my cosine of x is positive, okay? And so now if we do the inverse of cosine, so we're asking ourselves, what angle is the cosine equal to 1? Cosine is your x, okay? Where do you have 1 as your value?
0 and 2 pi.
0 and 2 pi, okay? So you have a repeat, right? So we would have our solutions as 0, pi, and 2 pi. Okay? Okay, let's move to the next question, which was number 71. Seemed like when we got to 69, then they got a little more difficult. I'm not saying that we had problems, they just got a little more difficult, okay? Okay, so we have this problem, and again, it's under the same heading. Let me get my book and read the directions so that we're not just making up answers or just doing our own thing here. Okay, so in this section it says find all real numbers in the interval 0 to 2 pi that satisfy each equation. Okay, so that's what the instructions are, from 0 to 2 pi. Okay, so when you look at this one, do you see anything that comes to mind as far as an identity? Okay, 1 plus our cotangent squared over here on the right side, we have an identity that says that is equal to our cosecant squared. Okay, that's one of your Pythagorean identities. Okay, so be sure you go back and review those. So, now, I'm not going to do anything on the left side just yet. Cosecant squared of x plus cosecant of x equals, I'm going to put these two together and rename it as cosecant squared of x. And what do we know that cosine of negative x would just be?
Just cosine of x.
Cosine of x, because it's an even, okay? So we're just going to change that to cosine of x. Okay, so then we have cosecant squared on both sides, so those would cancel out, right?
Yes.
So now we have a very much condensed equation, cosecant of x equals cosine of x. Now, so we've got to try to determine when would the cosecant of x be equal to the cosine of x. And we're going to approach it very much like I did the other one, as far as getting it set equal to 0, okay? But I'm going to change this cosecant of x to, let's use a sine, okay? It would be, cosecant is 1 over sine, okay? Because if I set it equal to 0, we know where sine is equal to 0, right? If I can do the factoring idea and all of that, okay? So 1 over sine of x minus cosine of x, and so that would be equal to 0. So what do you think next? Like we did on the last one.
Is them both equal to?
No, we don't have it factored yet.
Oh, yeah, common denominator.
Common denominator. Okay? We have to have factors to set them equal to 0. So we need a common denominator. So our common denominator would be sine of x. So we have 1 minus cosine of x, sine of x. over sine of x equals 0. Now, think of last time. What did we do when we had that denominator?
We multiplied.
Both sides by that, right? To get rid of it. Multiply both sides. Okay, so we end up with, and of course 0 times sine of x will still be 0, so we just have 1 minus cosine of x times our sine of x equals 0. Now, not quite as lucky as last time because we don't have anything to factor out, but do you recall something that we had where we had actually sine of x, cosine of x? One of our identities. Yeah, okay. But it was 2 sine of x, cosine of x, right? Okay? So we're going to work toward that. So now we're going to move this back over here. So we have 1 equals, and I may be taking a longer route here, but this is the way that it seemed to make sense to me, okay? And I'm going to switch that around to sine of x, cosine of x. Now, since I know that I had that identity that said the sine of 2x equals 2 times the sine of x, cosine of x, remember that one? Okay? So I'm going to multiply, see, I need this 2 right here. I've got the sine x, cosine of x, so I need to multiply everything by 2. Okay? So multiply both sides by 2. So we end up with 2 equals 2 sine x, cosine x. And once again, and if you can, using 2 different trig functions, if you can factor and set the factors equal to 0, so you have one trig function in one factor and one in the other, that works. But if you can't, then you need to try to condense it down to just one trig function so that you can work from there. So then we have this 2 equals, this would be sine of 2x, right? Now then, what do we know about the sine graph and how far it goes, its range? From -1 to +1, right? So if we get the sine of something to be 2, that would only be if you had an amplitude out here in front, right? And we don't have an amplitude out here in front. So it's not ever going to be 2, okay? So what would that be? No solution, okay? All of that for no solution. Sine must be between -1 and 1, unless you've got an amplitude applied to that. Okay? But again, those trig identities, we use one at the very beginning, then we use this one here. Okay? Okay. We good there? Yes. Okay, let's move to the next one, which is number 75. Okay. Now, I took this a different route. Then I looked it up in the solution manual, and they had a different route. Let me just tell you what they did, but I'm going to do it the way I saw it because, you know, remember, and I don't remember for sure how much we even covered, sum to product identities, but I didn't make y'all memorize those. You can look in the back of your book at those. Sum to product identity. And so that didn't pop in my mind right off, okay? So we have the sine of x plus the sine of y is equal to 2 times the sine of x plus y divided by 2 times the cosine of x minus y divided by 2. That's what that identity is. And since you've got a sum here, you've got 2 different sine arguments right here, the x and the 3x, you could change it to this. Okay, now as we get down as you got part of the way through it, then it ended up being like the way I approached it. Okay? I'm going to do it like I saw it because it made sense to me, because I remembered. Okay? I remembered from back when we were doing, and we had like a 2 sign, okay, or something like that. We did it as a sign of x plus a sign of, with x plus x in there. We broke it apart. Remember doing that? Okay? So that's what I did with this one. I did, okay, sine of x plus the sine of 2x plus x equals 0. I just broke that 3x apart as 2x plus x, because I know that if I have this 2x plus x, then I have the identity that says sine of alpha plus the sine of sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. I don't remember what it's called. Let me look in my book to get the name of it. Sine of a sum or difference. Okay? Let me write it over here. You have the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. We did that one. I know we did that one. Okay? And that's what I thought of when I saw this, was that, oh yeah, we've done this. Okay? So now I'm going to rewrite this in this form now. Okay?
In between that one, isn't it supposed to be a minus? Because you're adding?
No, on the sine, it keeps
yeah.
You have sine, cosine. It's when you have cosine that it changes the sign in between there, but it's cosine, cosine, sine, sine. Okay?
I see it.
Okay. So we have the sine of x plus, now I'm going to take this and rewrite it in this form. We would have the sine of 2x times the cosine of x, and then plus the cosine of 2x times the sine of x. And that's equal to 0. Now, then, I was working to that sine of 2x. We just came off of one like that, okay? So now I'm going to take this sine of 2x and rewrite that as 2 times the sine x cosine of x. Sine of x plus, taking this sine of 2x, okay? So I have 2 times the sine of x cosine of x, but it's multiplied times another cosine of x. I'll just be real honest with y'all here. The first time I did this and I did that cosine of 2x, I chose the incorrect identity for the cosine of 2x. You have 3 choices there, okay? And I chose the wrong one. So if you choose the wrong one, try again. That's all I can say. I tried again, okay? So this cosine of 2x needs to be 2 times your cosine squared of x minus 1. That's one of your choices there. But then you have that times the sine of x equals 0. Okay, now let's see if we can clean this up a little bit. We're going to keep our sine of x out here in front, plus 2 sine of x, and this would be cosine squared of x, because I have a cosine x there. It's kind of smudgy, but that's what it is. And then I'm going to distribute this sine of x to both of these parts here. So we have plus 2 cosine squared of x times the sine of x, and then minus the sine of x. And that's equal to 0. Okay, now let's see if we can get rid of some of this, or condense it a little bit. What do you see that will cancel out?
Sine of x.
Okay, we have a sine of x here and a negative sine of x, so we're going to do that. Okay, what about these 2 pieces? Not the same order, but you have a cosine squared and a sine, right? In both of them, and you have a plus 2 and a plus 2, so that would be how many of those? 4. So we're going to have 4 sine of x and then cosine squared of x equals 0. Now, these are multiplied together, so now we've got factors, but we don't want that 4 there, so what can we do?
Divide by 4.
Okay, divide both sides by 4. Divide by 4 all the way through. So we have sine of x cosine squared of x equals 0. Now, this is factors because it's sine of x times cosine squared of x, so we're going to set those factors equal to 0, since we have it set equal to 0 over here. Cosine squared of x equals 0. Okay, so here on this cosine squared of x, what would we need to do? Square root. Okay, so you can take the square root, and so we just have cosine of x equals 0, because square root of 0 is 0, and the sine of x equal to 0. So, where's our, and so you can write that as the inverse, if you want to. I don't always do that. Okay, so we're asking ourselves, where's the sine equal to 0? Where's our sine? What angles will we get 0?
0, pi, and 2 pi.
And 2 pi. We did that one a while ago, or had that same equation. Now this one's a little different because a while ago we had cosine of x equal to 1. Now where's cosine of x equal to 0?
Pi over 2 and 3 pi over 2.
And 3 pi over 2. Okay? So we would have those as our solutions. Okay? 0, if we put them in order, pi over 2, pi, 3 pi over 2, and 2 pi. I don't require that you put them in order, but the book will. The book puts them in order. I don't know that the book requires it, because they're not the ones grading the papers. Okay. Are we good?
Yes, ma'am.
Now that one was a little longer, I think, maybe doing it that way. I don't know for sure, because the other way, it did work out nicely, okay? So you could, but that's not an identity that I had y'all memorize, okay? So it didn't come to my mind. Okay, now to 77. We're making good progress, y'all. Okay, now look at what we have here. First of all, we have a negative with our cosine, so that would make it just
Cosine of 2x.
cosine of 2x. But this negative of the sine of negative 2x would make that a,
Minus sine of 2x.
okay, minus sine of 2x. But that minus, because this is multiplied, that negative and that negative will make this a positive. So let's rewrite that way then. Cosine of x times the cosine of 2x, and then it's going to be a plus sine of x times a sine of 2x equals the square root of 3 over 2. Now, does this look familiar to you, where you have cosine, cosine, sine, sine? Yes. Okay. Cosine, cosine, sine, sine. So what does it condense down to?
Cosine
Cosine.
of alpha minus theta.
Right, because this is a plus, okay? This would be when you condense it, it's cosine of the difference of these two. Right, okay? So we're going to write it that way, okay? So we have cosine of x minus the 2x, because this is a plus, and this becomes the minus in here, okay? And that's going to be equal to square root of 3 over 2. So it's just, we've seen, I guess, more this time, maybe than when you verified, that they're giving us a big, long, the expanded version of that, and we're wanting to condense it in, okay? So you've got to know them both ways, okay? Not just that this changes to that, but I can look at that and say, oh yeah, I recognize that, okay? So it's really just a matter of, can we recognize those identities when they're in a problem? Okay, so then this would be the cosine of, what's x minus 2x? Negative x. Don't be afraid of that. Okay, and then, again, we have the negative there, so that's going to be
Cosine of x.
cosine of x, okay? An odd an even function, equals the square root of 3 over 2. So we're saying the inverse function of inverse cosine, square root of 3 over 2, equals x. In other words, at what angles is x square root of 3 over 2? Is the cosine, not x, but the cosine, okay? So remember, cosine is your x. So your x has to be the long piece, okay? X has to be the long piece, because you know your hypotenuse is the 2. So it's this angle right here, and what's that angle right there?
Pi over 6.
Pi over 6, okay? Now, where is cosine, because this is a positive, where is cosine positive besides quadrant 1?
Quadrant 4.
Quadrant 4. So it's going to be this angle over here, okay? And that's almost to your 2 pi, so what is it?
11 pi over 6.
Good. So we have pi over 6 and 11 pi over 6. So that one wasn't too bad. If you remember, now this first part was just our even and odd, remembering that part of it, and then that one identity that we needed to recall. Okay, everybody good there?
Yeah.
Okay, moving right along. 79, and let me tell you, this one was a little bit of a challenge, okay? Because it had some extraneous solutions, okay? And we said last time, always check, because you can have an extraneous solution when you square both sides, okay? That didn't actually happen here, but we also have to think of where, if you've got functions that are not your sine and cosine functions, where they would be undefined. And that's what happened on this one, okay? And I'm saying that at the beginning because I don't want to get cut off and not have it finished, okay? So we had to double check. So look at this and this piece. Do you recall something from one of our identities that kind of looked like that, but maybe not with an equal sign in between it? Okay, let me help you out. The tangent of alpha plus beta is equal to this in the numerator, okay? The tangent, well, with alpha and beta, alpha plus the tangent of beta, and this in the denominator, 1 minus tangent of alpha, tangent of beta, times the tangent of beta, okay? That was one of your identities. So we need this over here as a denominator, okay? So we're going to divide both sides by that. We're going to divide through by the 1 minus tangent of x, tangent of 2x. So we're going to have then tangent of x plus tangent of 2x over 1 minus tangent of x, tangent of 2x, times, that's a product right there, equals, when you divide something by itself, we get 1, right? Now, we want to take this and go to its condensed version, okay? Like I said a while ago, it seems like these, we're taking the expanded and we're going to condense it down. So what would this be equal to? Tangent of?
X plus 2x.
There you go, x plus 2x equals 1. Okay, so we end up with the tangent of 3x equals 1. Now this one I am going to write using our inverse tangent because we need it written that, because we don't just have x there, we have a 3x. Okay? So for what we want to do first is just think of the angles where tangent is 1. And it's a positive 1. So what angles do we have where, or radian, okay, where tangent is equal to 1? Pi over 4. And
5 pi over 4.
5 pi over 4, okay? 180 degrees over here, okay? 5 pi over 4. Now, because we've got that 3x, we've got a little bit more to do, okay? So we're going to put 3x equals pi over 4, and we're going to put 3x equals 5 pi over 4. Okay. So if I divide by 3 on both sides, that would give me x equals pi over 12. You're multiplying by 1/3, right?
Mm-hmm.
Okay. And here we would have x equals 5 pi over 12. Okay? Now, that isn't all the way around to 2 pi because we've got to have our x value from 0 to 2 pi. So now we're going to have to keep going around this circle till we get all the way to 2 pi with my values. Follow what I'm doing?
Yes.
Okay? So because we're right here, like right pi over 12 right here, and then 5 pi over 12 wouldn't even be to pi over 2. Okay? It's going to be up here. So we're going to have to make our journey all the way around this unit circle with other places where it's going to be equivalent to the pi over 4. So I went back up here and did like another time around. So if I added 2 pi to pi over 4, because from pi over 4, if we want to go a full circle around, we're going to add 2 pi, right? Okay? So 2 pi is equal to 8 pi over 4, right?
Mm-hmm.
So if I add 8 pi over 4 to this pi over 4, that gives me 9 pi over 4. Okay? Now, multiply that times 1/3 and you have 9 pi over 12. Now, do the same thing over here. Add an 8 pi to this 5 pi over 4, which will give us 13 pi over 4. And so then when I multiply that by 1/3, excuse me, not 3, but 1/3, I have 13 pi over 12. You still with me? Now, we're still not all the way around to 2 pi, because 13 pi over 12 would just be barely past pi, right? Okay, so we got to go again. So we're going to add another 8 pi here, and we end up at 17 pi over 4. Watch the clock for me, folks, please.
Okay.
And if we add another 2 pi over here, which would be 8 pi over 4, we end up with 21 pi over 4. You good there?
Yes, ma'am.
And then if you multiply those by 1/3, you have 17 pi over 12, and here would be 21 pi over 12. Okay. Now I told you early on that this one had extraneous solutions, and you're just going to have to be aware that there could be, okay? So we have to think back at our original equation, or at these values, okay, which this one would actually simplify to 3 pi over 4. Where is tangent undefined? Okay, well, it's at 3 pi over 2 down here, because it's sine over cosine, okay, right? Okay, so 3 pi over 2. So when we plug this in up here to this 2x, the 3 pi over 4 times the 2 becomes 3 pi over 2, right? So you have a part of this original that is undefined.
Okay.
So this is an extraneous solution. And then, okay, it would also be undefined at 7 pi over 4. Okay, so when we had our 7 pi over 4, which this is it, okay, 7 pi over 4, because when you plug in that to your 2x, okay, you end up with 7 pi over 2, which would be another revolution around. So it's undefined at these two values. So our solution set is just the pi over 12 17, and these aren't in order, folks, 17 pi over 12, 5 pi over 12, and 13 pi over 12. Conference is about to end. Okay, again, everybody, if you have other questions, let me know. I'm going to scan these and post them also. Oh, thank you. I thought I was going to say that. Okay, what I needed to talk to y'all about. I was totally not thinking right and hadn't paid attention to the posters. The advising next Friday actually begins at 8:30. So, I am willing to get here 7 o'clock, whatever time. I'll be here at 7 o'clock, or unless you want to change it to another time. I will work with y'all whatever way I can for that second part of that test. If we need to take it later in the afternoon on Wednesday or Thursday, you let me know what we need to do.
What do you guys?
You don't all have to be here at the same time, okay? So
Okay.
you look at your calendar, and you, or not here, but over in the math building, okay? If you feel like that would be just too much pressure on you to try to finish it and get over to the advising,
The second part's not as long, is it?
I don't think it will be, okay? And oh, I should have said, I'm not real sure. I know the second part, the first part will not contain 5.1 and 5.2 and those application problems. But I'm not sure how much of chapter 4 will have to be on the second part to make it kind of even, okay?
For the first part, is it with calculator or with?
The very first part of the first part, just a,
Yeah.
10 minutes, 8 minutes maybe, whatever, okay? Maybe even just
the
5
second
minutes.
part?
The timed part is gonna be part 1, and that's Wednesday. Then after we finish that, then you get the rest of the time for the rest of part 1.
Okay, but I'm asking, are we gonna be able to use calculators?
The other
Or do we
part,
use the part?
yes, the other part of
Part one?